presentation focuses on three essential components of practical navigation. First, we have the plotting routes, avoiding navigation hazards, and calculating the estimated time of arrival or the ETA. With that, I will now begin the presentation. First, what is mini voyage simulation? A mini voyage simulation is a specific type of training simulator in the maritime industry. It is a scaled-down version of full mission-grade simulator designed to provide realistic training for tasks such as voyage planning using ECDIS, electronic chart display and information system, adhering to call regs, conversion on the international regulation for preventing collision at sea, and watchkeeping. It helps trainees to learn safe and effective navigation in a realistic but controlled environment. And now let's proceed to the importance in navigation training. First, we have the enhancing safety here. Training develops the ability to avoid accidents by properly understanding condition and using equipment correctly, which is critical for protecting lives and vessels. So it improves safety by teaching us how to recognize condition, use equipment correctly, and avoid hazard. It helps to prevent accidents and protect both life and vessels. Next, we have the improving decision making. In trained individuals is to respond to changing conditions and solve problems, a skills that is particularly important under stress. Training strengthens decision making under pressure. So it prepares us to respond quickly to changing conditions and solve problems effectively. Next is the developing essential skills. Training covers a wide range of skills from using specific navigation equipment and understanding concepts like latitude, longitude to develop crucial mental skills. So navigation training builds the basic skills every seafarer needs, like using navigation tools, reading charts, and understanding coordinates. So this is very fundamental to make a safe and accurate navigation possible. So next, we have the boosting efficiency. So component navigation is vital for global shipping industry, where precision in guiding vessels is necessary for the efficient transport of goods. So proper navigation increases efficiency by ensuring vessels travel accurately on time. This is very important for smooth and reliable operation in the shipping industry. And lastly, we have the maintaining situational awareness. Effective training helps develop and maintain situational awareness, the ability to understand the surrounding environment and anticipate future events. It develops situational awareness, the ability to understand environment, identify risks, and anticipate what will happen next. So this is the key for a safety navigation. And now let's proceed to the required tools needed for mini voyage simulation. First, we have the nautical charts, detailed marine map showing coastline, depth, hazard, buoys, landmark, and safe navigation routes. So used shows coastline, depths, hazard, landmarks, and safe routes. Next is the divider, a two-pointed measuring tools for making distance on charts. So it measures nautical miles on the chart, latitude scales used to check distance between waypoints. Next is the parallel ruler or triangle, plotting tools used to transport straight lines and bearing across a chart. It used for plotting a course line, transferring a bearing from the compass rose to your route. Next is we have the compass rose, a circular diagram printed on nautical chart showing direction. It provides a true and magnetic direction reference for plotting process. Next is the sailing direction. So a navigation reference book describing coast, port, current, weather, and hazard. So it provides description of ports, hazard, landmarks, and navigation advice. Next is the tide current tables. So books on charts showing daily tide heights on ocean current direction and speed. So it's used for calculating the ETA affected by current, determining safe departure times, and predicting water depth. And lastly, we have the logbook, the official written record of the vessel voyage. So it's used for recording speed, course time, and weather, documenting events during the voyage. So now let's proceed to the understanding the chart. chart symbols are graphic presentation that shows features and possible hazard on nautical charts. Mariners should use official reference like MOA nautical chart symbols and abbreviation documents to understand the meaning of symbols of things like buoys, light, wrecks, and shorelines. So we have the scale of chart. So the scale of chart is a ratio such as 1:80,000 that connects a measured distance on the charts to its actual distance in the real world. It helps the mariners accurately gauge real distance for navigation. Second, we have the large scale charts. Like harbors, charts represent smaller areas with greater details. They are best for navigating restricted or complex water with precision is important. And lastly, we have the small scale charts, such as those for the open ocean, cover much larger area but with a less detail, making them suitable for long distance travel. Next, we have the depth surrounding and compass rose orientation. For the depth surrounding, so our numbers on chart showing water depth at specific points measured in the feet, fathoms, or meters. These depths are used to standard reference like the MLLW or the LTA, meaning actual depth is usually deeper unless during extreme low tide. So it helps the navigators to avoid shallow areas and ensure safe passage. For the compass rose orientation, the compass rose orientation shows a direct using two rings. The outer right points to the true north while the inner ring points to magnetic north. It also displays local magnetic variation and its yearly change, helping the navigators convert between true and magnetic direction accurately. So at this slide, we have the starting point and destination is a starting location from which a journey begins, and the arrival point B is the final destination where the journey ends. The departure point is where you are now, and the arrival point is where you want to go. Departure point A, this is the region of a route or journey. In navigation, it is your current known position, which can be defined by coordinates like latitude and longitude or a reference to a landmark. While the arrival point B, this is the end point of a goal or a journey. It is a location you are traveling and can also be defined by its coordinate or a specific point. And now let's proceed to the plotting of route. So it is a step-by-step route plotting. For first, we have the mark your starting position. So first, you have to identify your current position in the nautical charts, usually using latitude and longitude coordinates or visual bearings from fixed landmarks. So mark this position on chart and often with a dot inside a small circle or triangle and label it with the time in 24-hour format. Second step, we have the select and mark waypoint. So identify your intended destination and any intermediate waypoints which are turning point along your route. Second is to ensure the planned route between the waypoints avoid hazard like shallow waters, rock, or restricted areas by checking depth contours and symbol on the chart. So mark each waypoint typically with a small square or a cross and label it. So the third step is determining courses between waypoints. Keep one edge on the parallel rulers aligned with the drawn cross line. So walk the rulers across the chart to the nearest compass rose by holding one ruler fixed while moving the other. Then switching and repeating the process, ensuring the angle does not change. And align the edge of the ruler with the center of the compass rose and read the true course, like direction of travels from the outer circle of degree. And the fourth step is measure and mark distance. So use divider to measure each route segment. Compare it to the latitude scales to find the distance, which 1 minute of latitude equals 1 nautical mile. Write the distance next to the course line. So now let's proceed to the identifying hazards. So shallow water, shoals, and banks. This area pose a grounding risk for vessels with significant drafts. They are often indicated by depth surrounding on navigation charts. And next, we have the reefs and rocks. So these are cause severe damage or sinking. So they are clearly marked on official charts with symbols like submerged rock symbols or magenta colors for drying rocks and accompanying labels. And next, we have the traffic separation zones or the TSS, established to prevent collision in busy shipping lanes. These areas have specific lanes of travel and often a separation lane or separation zone that vessels should not be across except under specific condition. They are marked on chart with specific lanes and arrows. And lastly, we have the restricted area. So these are the zones where navigation is limited or prohibited. So often due to a military operation or environmental protection like marine sanctuaries, or it could be a security concern. So they are marked with specific boundaries, lanes, and explanatory text on charts. Next, we have the speed and ETA. To calculate time and estimated time of arrival for the ETA using speed in knots, you apply the fundamental formula: time equals distance over speed. Our key terminology in navigation, we have the distance measured in nautical lines, which stand for nm. The speed measured in knots or the KTS, which are nautical lines per hour. So for the time, it's calculated in hours. Calculating steaming time is to find the duration of a voyage, divided the total distance by the average speed. So the formula is time equals distance divided by speed. So this means you divide how far you will travel and how fast you are moving. So for example, you have a distance of 5,760 nautical miles. You have to divide it to 20 knots. It is equals to 288 hours. And next is you have to divide it to 24 hours, equals of 12 days of traveling time. And for our next slide, we have the importance of route planning. So, route planning ensures safe navigation by avoiding hazard, improving voyage efficiency, and reducing fuel use. It is also support compliance with maritime regulations and minimize the risk of collision, grounding, and delays. Second is the skill gained from simulation. The simulation builds key navigation skills including interpreting nautical charts, plotting courses and waypoints, calculating distance, speed, and ETA, and making informed decisions to identify and avoid hazard. And the last part is the real-world application. So these skills are used daily by desk officer for voyage planning, watchkeeping, and coastal or open sea navigation. They form the basis of advanced navigation system like ED and strengthen situational awareness and overall maritime safety. That's all for my presentation, and again, this is JN Tao Poclarit, BSFI 4A, signing off.